We did LRAM, MRAM, RRAM yesterday. There is something called lower Riemann sum and upper Riemann sum. This is not tested on AP, but the reason why I'm bringing this up is because maybe your professor at the university will talk about it. Like A&M College Station is going to talk about this for sure. And I don't want you to be there and be like, Chom didn't talk to me about this. He just talked about LRAM, MRAM, and RRAM. This is lower Riemann sum, not to be confused for LRAM. Sometimes the lower Riemann sum can be an LRAM if you have like a strictly increasing function, but that's not the case. So let's just see it. And it is coming from UH, so you can see what's coming up next. Compute the lower Riemann sum for the given function x squared. So this is a strictly increasing function between -1 and 1 with respect to partition. Well, it's increasing between 0 and 1, but decreasing between -1 and 0 with respect to the partition. So here are the partitions. So that's how you're going to break it up. So let me draw, and I'm going to exaggerate. Let's make it big. So let's draw really big x squared between -1 and 1. So here it is. I'm going to claim that this is -1, and I'm going to claim that this is 1. Nothing crazy, right? So see how it says lower? The key word is lower. So that means you're going to pick the lowest point on that partition or this little interval. So my first rectangle, here's my first one, between -1 and -1/4. So -1/4 is probably like right, let's see, here's half. So here's like -1/4. It's -1/4. So these do not have delta x's that are equivalent. The next one is at half. So boom, right here at half. And 3/4. So 3/4. Okay, here we go. Between -1 and -1/4. What point do I have the low on the curve? What point is the lowest? Is it okay for now there? Because I didn't. So yeah, on the curve. Yeah, -1/4. So put a point at -1/4 and go boop, boom. There's your first rectangle. Look at this next one. Between -1/4 and a half, where do I have my lowest point? Yeah, it's 0. So you don't have a rectangle between -1/4 and a half. Between a half and 3/4, bless you. Between a half and 3/4, where do I have my lowest y value? At a half. So there it is. And between 3/4 and 1, where do I have my lowest y value? At 3/4. This is called a what? A lower Riemann sum. So when your professor says, show me a lower Riemann sum, that's what they want.
The same thing we're doing, it's just in respect to a different y value.
Yeah, it's just, it's play on words, I guess. It's just lower. Is this on the AP exam? No, but MIT might want you to know this if you go there. A&M College Station might want you to know this. UT Austin might want you to know this. UCLA. Okay, I'll stop. All right, let's figure out what these areas are. So all I'm doing is width times height, guys. So the area of this rectangle there, let's see, that is going to be, what's my delta x there? 3/4? 3/4 times the height. The height is dictated by x squared. So -1/4 squared. Does everyone see how I got that? Plus, I know this one's 0, guys, but I'm going to show the work. Let's see, 1/2 plus -1/4. That's another 3/4 times 0 squared. Does everyone see how I got that? Okay. Plus, the gap between 1/2 and 3/4, that's like 50 cents, that's like 75 cents. So that is 1/4. Do you guys see how I got the 1/4? And then the height is dictated by the y value, 1/2 squared. Plus 1/4 again, 3/4 squared. There it is. That's my total area. Put it in the calculator and tell me what that number is. So let's see. 3/4 times, I already forgot, -1/4 squared.
Can we just square them all and then multiply by? Oh, no.
Yeah, because this time the delta x's are different, right? Plus 0. So I'm not going to bother with that one. 1/4 half and 1/4 3/4. Okay, let's see if I can remember that. 1/4 with a half squared plus, and I guess I could have factored out the 1/4, but I already stopped here. So 1/4 times, I already forgot, 3/4. And 0.25, so 1/4. Is there a 1/4 in there?
Yeah.
There it is.
Pretty straightforward.
Yeah. Let's go to the next page, guys. One more. I should have done an upper sum instead of a lower sum, but that's fine. Compute the lower Riemann sum for the given function. The function is sine x between 0 and pi. And here are the partitions. So here's my sine x. I'm going to exaggerate it. Yeah, it looks okay. Where here's power 2. And the height is 1. Here's 0. Here's pi. All right, it tells me between 0 and power 6. So let's see, power 6 is probably really close here. Like right there. Power 6 is 3 power 4. So 3 power 4 is right smack in the middle between power 2 and 3 power 2 and pi, sorry. 3 power 4 and pi. So there it is. So I only have 3 rectangles. Well, technically just one. So look, lower Riemann sum. What's the lowest between 0 and power 6? 0. So I'm going to go to 0. I'm going to do it in black. 0. So here's my first rectangle, so you don't have one. Between power 6 and 3 power 4, which one has the lower y value? Power 6. So go to power 6. 3 power 4. And between 3 power 4 and pi, where's the lowest point on that curve? At pi. So you only have, technically you only have how many rectangles?
One.
Just one. Let's figure out the area of that rectangle. I'm going to go slow, don't worry. The other ones are 0, yep. So all I'm doing is width times height. That's all I'm doing. So the width, I don't know, whatever 3 power 4 minus power 6 is. So 3 power 4 minus power 6, whatever that is, times the height. What is sine of pi over 6? Sine half. There you go. I guess let's find the answer. Common denominator, I guess, right, on this one over here. So let's see, that's a 6, that's a 4, so 12. So multiply this by 3 over 3, multiply this by 2 over 2. I'm doing a common denominator of 12, guys. So let's see what we got. So 9 pi over 12 minus 2 pi over 12. This is still in parentheses times half. What's 9 minus 2? So 7 pi over 12 times half. Okay. What's 12 times 2? 7 pi over 24. Is there a 7 pi over 24? There it is. If it would have said upper, we would have chosen pi over 6 for the first rectangle. Let me choose a different color. Do I have pink or something? Let's do purple. If it would have said upper, don't write this down, guys, because it's not asking for upper. I would have chosen pi over 6. And between pi over 6 and 3 pi over 4, my biggest is at pi over 2. See? If it would have said upper. If it, say it again. No, it's the highest point on the interval, on the partition. Correct. See how at pi over 2 it's the highest? And between 3 pi over 4 and pi, if it would have said upper, I would have done those 3. Do you guys see that? Okay. I'm going to delete them because it's not asking for upper. And I'm going to delete the word upper. What's up, Rodriguez?
I know that 1/2 by doing the sine x of pi.
Sine, this.
But why did we choose pi over 6?
Oh, because at pi over 6, that's what that y value is, whatever this is. And the function is sine x. So if I type in a pi over 6 into my x, that'll tell me the y value. Because area of a rectangle is width times height. And I need to know the height of this rectangle in black.
Why did you choose 3
Well, because 3 power 4, I'm not on the. It's not touching the curve. See, if it would have been touching the curve, then I would have needed that height. Do you know what I mean? Okay. Do you see the logic? Okay. All right, guys. Don't worry. In the next 10 minutes, we'll be done, and then we'll set you guys loose. You have one delta math. I hope that you're happy. The estimated time on that delta math, guess what delta tells me that it's supposed to take you? 14 minutes. So you got so you'll be done by 9:10, 9:15, and you can do whatever you want with your time. All right, so it says, check out the sum below. 1 over 1, 1/4, 1/9, 1/16, 1/25, 1/36. And then observe that the denominators are all perfect squares. Do you guys see that? You can make, and there's an obvious pattern in the sum. The terms in the sum are reciprocals of squares, 1 squared through 6 squared, written in sigma notation. You could write it as, so this stands for sigma, not to be confused with the term, oh, he's a sigma. That stands for sigma, and what it means is sum. And I'll show you where that's at in the calculator. And all you do, how do you use it? For you guys in statistics, you guys already know. You start in the lower one here, and you stop in the upper one. And you just go in terms. Wherever you start, you're going to go, it's in whole numbers, integers. Well, the n, but you can have whatever you have in there. So that is not the only way to write this expression. Can you think of other ways? Yes, you could have done this. You could have said here like that, and I could have said, and it doesn't have to be the letter J. It could be any letter, but usually it's I, J, or K. So I'm going to write K. K equals 0. And if I start at 0, then I have to do this, 1 over K plus 1. And if I start at 0, then I'm going to go all the way to 5. Because look, 1 over 0 plus 1 squared. Oh, put a square there, sorry. Plus 1 over 1 plus 1 squared. Plus 1 over 2 plus 1 squared. Plus 1 over 3 plus 1 squared. Plus 1 over 4 plus 1 squared. Plus 1 over 5 plus 1 squared. Equals 1 over 1 plus 1 over, what's 2 squared? 4 plus what's 3 squared? 9. What's 4 squared?
16.
What's 5 squared?
25.
What's 6 squared? Did I get the same thing that I got up here? And notice I have a different number, a different stop, and a different stop. I have a different start and a different stop. So there's actually many ways you can do this. Does that make sense to you guys? And that's all it is. For those of you that have taken statistics, this is probably a walk in the park for you because you've been using sigma notation for a long time now. Cool or not cool? Yeah, so that's it. That's it. We're just practicing. So here we go. Let's try a few more. Let's see if we can do this. And then in a little bit, I'll show you with a calculator. All right, so where do I start with this one? Letter A. Start at 1, and then you're not going to stop until you reach what number? 1 plus 2 plus 3 plus 4 plus 5 plus 6. All right, let's add that up. 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 4 is 10. 10 plus 5 is 16. 16 plus 6. Oh, did I say that? Did I say that? Oh, 10 plus 5 is 15. I didn't say that? Dang, that's crazy. And then 16. Look, I said it again. 15 plus 6. 21. All right. Chop, how do I do this in the calculator? Because that looks like cumbersome. All right. Everything can be done in the calculator. Do you see a button that says math? Okay, push it. Scroll down until you see something called sigma or sum. Do you see it? On mine, it's 0. Is yours 0 too? Push that. You should get something that looks like this. Let me know if you don't. So I can use any letter here, but to make it simple, just push X. And then where do I want to start at? Let's see. This one starts at 1. So I'm going to put 1. And then I'm going to stop. I'm going to stop at what number? 6. And then I'm going to come up here. And then instead of writing the letter I, I'm going to put whatever letter I use. What letter did I use? X. And then I push enter. And then look at that. Cool, right? And there it is. So now you know another tool on how you can use this calculator, guys. All right, here we go. This one says I plus 1, so I'm going to start at 0 and stop at 5. 0 plus 1, close plus open. 1 plus 1, close plus open. 2 plus 1, close plus open. 3 plus 1, close plus open. 4 plus 1, close plus open. 5 plus 1, close. And that's what you're adding. 1 plus 2 plus 3 plus 4 plus 5 plus 6. This looks like it's exactly like the top. So this better give me 20, 21. No? How do we feel? Look at this next one. I start at 3. 3 squared plus 4 squared. All I'm doing is whatever it tells me the expression to do. It says j squared. 3 squared plus 4 squared plus 5 squared plus 6 squared plus 7 squared. There it is. Let's see what this is. 9 plus 16 plus 25 plus 36 plus 49. I don't feel like adding all those. I mean, I guess you could. I'm just going to use my calculator, put j squared in there, 3 to 7. What is that number? 135? I believe you. It feels like it's about right. Did you use the formula or did you add them all up?
I just added.
Oh, okay. Did someone use the formula and get the same thing? Look, I can just scroll up and just push x squared. And where was the start? 3 and what was the end? 7. 3, 3, 7. There it is. See? It works. Cool, right? All right. Chop, what about this one? Okay, whenever you see the n there, usually that's because they're probably going to have something in the front like limit as n approaches infinity. That's what we're getting to. We're not there yet. Hey, no yawn. You're going to make me yawn. So every term's going to have a 1 over n. It says k, so wherever there's a k, that's where I'm going to start. So here's how you do it. Chop, am I going to do this forever? No, we're going to signify it with 3 dots. So it has to have 3 dots. So you're going to go 1 over n, parenthesis, and we're going to start at 1. So 1 squared plus 1, close it. Plus. Are we okay so far? The next one, you're still going to write 1 over n, parenthesis, 2 squared plus 1, close it, plus 1 over n, close it, 3 squared plus 1, close it, and then usually this is enough, 3 terms, and then go plus, and then put 3 dots, dot, dot, dot. So why is this enough? Because with 3 terms, you can already tell the pattern. Do you see that? 1, 2, 3, like how we were squaring it? And now those 3 dots mean continue with the pattern. And then you're going to go plus, and you're going to go to the very last one. Sometimes some textbooks do the last 2 terms, but here's the very last one. The very last term, the n, so you're going to go 1 over n, parenthesis, n squared plus 1, close it. Does that make sense, guys? This does not have an actual number. I mean, I guess you can sum them up to infinity in terms of n, but it does not have an actual number at the moment because we don't have an n value. Does that make sense? And there it is. That's it. All right. We're getting really close to to integral notation here. All this is missing is a limit and then approaching infinity, and that will create that integral. But we're not there yet. So here it is. I'm gonna do the same thing that I did with the top, guys. F of x1, close it, delta x, plus f of x2, close it, delta x, plus f of x3, close it, delta x, plus dot, 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 plus f of xn, close it, delta x. This one is a little different than the one on the top because every term from here to infinity has a what in it? A delta x. So can I factor out that delta x? Yeah. So more than likely on most textbooks, you'll probably see it factored out like this, and you'll probably see this. Dot, dot, dot. Parentheses matter. Like Miss Kyle said. Cool? Parentheses matter, guys. All right, let's go to the next page. Don't freak out. We're done. We just got these last 2. Yes, you're right. We can do it with a calculator, but let's not do it with a calculator just yet. So let's see what this says. So they give me a function. A function is negative 2x plus 3. And they told me that it wants me to do this. So, all right, equals. I'm going to start at 1 and stop at 5. F of 1/2 plus 3 plus f of 2 over 2 plus 3 plus, am I going to be able to fit it? F of 3 over 2 plus 3 plus f of 4 over 2 plus 3 plus f of 5 over 2 plus 3. Let's see what that is. F of 3 plus a half, that's 3.5. I guess I'll write 3.5. Plus f of 2 over 2 is 1 plus 3, that's 4. Plus 3 plus 1.5, that's 4.5. So it's all increasing by 0.5. Plus f of 5 plus f of 5.5. Yep. So here's my calculator. We're going to do it two different ways. Click y equals. I'm going to put negative 2x plus 3. Negative 2x plus 3. So I'm going to show you guys how powerful this calculator is. So look, you can just go, let's clear this. Alpha trace y1. And where did I start at? 3.5. 3.5 plus alpha trace y1 at 4. You guys know what I'm doing? Plus alpha trace y1. Make sure you practice, guys, so you guys can know how to do it. 4.5 plus alpha trace 1.1 at y1 of 5. Was there a 5.5? Plus alpha trace y1 at 5.5. But there was no 6, right? Okay, so there's the last one. Bam. Negative 30. Now let's see. Look what happens. Math number, I think it was 0. So from x equals from what to what? 1 to 5. 1 to 5. And then look, guys, I can type in y1 in here. Alpha trace y1. And I can just type in the expression on the inside. What was the expression? K over 2 plus 3. So look, alpha y equals enter. So I can get that fraction. X over 2 plus 3. And close it, and then that should work. So let's see if it works. Enter. Look at that. Isn't that pretty cool? Yeah. So now you know it. Now you can start using this calculator for chemistry for every time you're doing summations. So there it is. This is just 30. Negative 30. All right, last one. Same deal. Same deal. So let's see. This is equal to f of, I'm going to start at 1. So 3 times 1 plus 3 plus f of 3 times 2 plus 3 plus f of 3 times 3 plus 3 plus f of 3 times 4 plus 3. Let's see what that is. F of 3 plus 3, that's 6. F of 3 times 2 is 6 plus 3 is 9. Plus f of 3 times 3 is 9 plus 3 is 12. So it's going to just be going up by 3. 6, 9, 12. Plus f of 3 times 4 is 12 plus 3 is 15. And that's it. So there it is. So I'm going to type y equals. And I'm going to clear that one. And I'm going to type in x minus 4. I'm going to go to my home screen. And I'm going to do the same thing. Alpha. Oh, let me clear all this. Alpha trace y1 evaluated at which one again? 6. 6 plus 9. Y1 at 9. Plus, what's the next one? 12. And then the last one's 15, right? Bam, 26. Let's see what happens when I do math 0. Of course, it's going to be the same. X equals, what does it start at? 1. And it ends at what number? 4. And then I'm just going to type alpha trace y1. And what was the expression on the inside? 3k plus 3. So I'm going to put 3x plus 3 And it should be the same thing, guys. Bam! Look at that. What do you guys think? Cool or not cool? All right, we're done, guys. Take care of the delta, and we'll call it a day.